So now we're going to look at the law of cosines. And the law of cosines is another way that we can solve triangles when it's not a right triangle. So law of cosines, we're going to use in two different cases. If we have a side, angle, side, or if we have a side, side, side. I would imagine on ACT, they will most likely provide you with these formulas, but here's the formula if you're looking for the sides, and it looks similar to Pythagorean. And then here are the formulas if you're looking for the angles. Basically, I just took this formula and solved for A, solved for B. And then let me show you what the C formula is going to be. So what you do is you have the two other sides, so A squared plus B squared. And then you always subtract the side that's the same as the angle, C squared. So this one's angle B, subtract B squared. This is angle A, subtract A squared. And then you're going to always put it over 2, and then this is AB, 2AB. And then in front of that, I don't have enough room. In front of that, you're going to use the inverse cosine. So this would be the inverse cosine of this, and that's what angle C is going to equal. Now you could always use this formula to find angle A, B, or C. It's just you would have to undo to get that angle by itself. So knowing the angle formulas is oftentimes very useful. So again, we're going to use it for side angle side or side side side. And so let's start with example 1. Angle A is 49 degrees and side B is 42 and side C is 15. Now, I always like to set it up A equals B equals C equals A equals B equals C equals. And so put in what you know. So angle A is 49, side B is 42, and side C is 15. And do you notice that if I line up my A's and B's, I only have 2 of the 4. And if I line up my B's and C's, I only have 2 of the 4. So in order to use law of sines, you have to have only one missing item, which is 3 of the 4. So this is how you know that you're going to use law of cosines instead of law of sines. Now, let's look at this and let's see what we have. So if this is triangle ABC, and you know this is 49, and you don't know what A is, and angle B you don't know, but you know across from it is 42, and you don't know angle C, but you know across from it is 15. Can you see how we have side, angle, side? A side, an angle in between, and a side. So this is what we call side, angle, side. And this is when we use the law of cosines. So with the law of cosines, let's start by using we're going to find the side of the angle that we have. All right, so that's what we're going to do. So the formula is A squared is equal to B squared plus C squared minus 2BC cosine of angle A. So A squared, we're solving for just A. So A is going to equal the square root of, and then let's plug in everything we know. So B is 42, 42 squared, plus C is 15, 15 squared. Subtract 2 times 42 times 15 times the cosine of A, which is 49. And this is going to give me side A. Throw that all into your calculator. You can throw it all into your calculator at one time. Make sure you're in degree mode. So you throw that all in, and I believe that we ended up with 34.093. Now we're going to use law of sines. And with law of sines, we don't want to run into the side-side angle problem. So what we're going to want to do is we are going to want to solve the bigger angle first. No, sorry, I said that wrong. The smallest angle first. So because 15 is the smallest side, we should look for C first. And I don't love that purple. Maybe I could use yellow. So we're going to look for C first. So here we go. Let's set up. And I know that this here showed that I used the A's and B's. When you use the A's and B's, you end up with an angle that's not going to work. And so then you have to take 180 and subtract that angle in order to get an angle that works. So I don't recommend finding angle B first. You need to go with the smallest angle first. So here you go. You would do the sine of C over 15 is equal to the sine of 49 over 34.093. And then you should remember how to solve this. You're going to cross multiply. So now you have the 34. Oh, I think I want to be in black. You have the 34.093 sine of C is equal to 15 sine of 49. And then you would divide by the 34.093. And anytime you're solving for the angle. So here I'm looking for angle C. So how do you get C by itself? You take the inverse sine. So in your calculator, angle C is equal to the inverse sine of 15 sine 49 over 34.093. Throw that all into your calculator and you are going to get angle C, which is 79.39. Is it 79 or 19? 19.393. 19.393. I'm going to stop and put it in my calculator to make sure because I can't read my writing. Yes, that is correct. And so then for angle B, you're going to take these two and subtract it from 180, and you're going to get 111.607. And I solved this triangle. Solving a triangle means you find all of the angles and all of the sides. And we don't use SOHCAHTOA because it's not a right triangle. So the other type of triangle that you use law of cosines on is when you have a side, side, side. So here, I don't know what angle A, B, or C are, but I do know what side A, B, and C are. Side A is 31, side B is 52, and side C is 28. Now there is a trick for doing side, 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 and that is you always want to solve for the largest angle first. This is going to help you prevent where you have to take 180, subtract the amount that's not going to work. So largest angle for law of cosines and smallest angle for law of sines. All right, so we're looking for B. So let's use our angle formulas just because they're easier. So angle B is going to be equal to the inverse cosine of A squared plus C squared, subtract B squared. If it's angle B, you subtract the B squared side over 2, and then you use AC, and that's what we're going to throw in. So here we go. Angle B is equal to the inverse cosine of 31 squared plus 28 squared subtract 52 squared over 2 times 31 times 28. Inverse cosine. You're going to take your calculator, you're going to hit second cosine, then green alpha, F1 fraction bar, enter. 31, hit the x squared key, plus 28, hit the x squared key, subtract 52, hit the x squared key, over 2 times 31 times 28. And this is going to give us the 123.533. So angle B is 123.533 degrees. Now we're using law of sines. And so with law of sines, go with the smaller. So we're going to find angle C first. So you're going to set up your proportion and figure out what C is. So I'll do the setup. It's going to be the sine of 123.533 over 52. And I actually store the number as letter B, and then I use the full number when I do these. And then this is going to equal the sine of C over 28. Keep in mind, because you're solving for an angle, you're going to use the inverse sine when it's all said and done. So finding C, I got 26. If you guys want to stop the video and try it, I got 26.670 degrees. And then we're going to just simply take 180 and we're going to subtract the 123.533 and then subtract the 26.670. And again, I would recommend grabbing the full numbers so that we're just exact and we get 29.797. So 29.797 degrees. Okay, so the next thing I want to show you is story. Actually, let's skip the story problem and let's just jump to area of a triangle. ACT may ask you for area of a triangle that is not a right triangle. So there are two formulas. ACT will most likely give you the formula. So if you have a side, angle, side, and you want the area of the triangle, then you're going to use this formula right here. Super easy to use. The area of that triangle is equal to 1/2. Multiply the two sides together. So 50 times 32, and then take the sine, not the cosine, the sine of 120 degrees. Throw that all into your calculator, making sure that you're in degree mode, and your area is going to be 692.820 units squared. Now, I've seen this on the ACT before, on the practice ones I've done, but they've always provided the formula. The last thing for today is Heron's formula. And Heron's formula is how to find the area of a triangle when you're given side, side, side. 5 meters, 6 meters, 9 meters. So what you do first is you find what's called the semi-perimeter. This is not an average because we're dividing by 2 and not by 3. So to find S, you're going to take 5 plus 6 plus 9 divided by 2. So 11 plus 9 is 20, and 20 divided by 2 is 10. Then you're going to use this formula right here. And again, I would be surprised if ACT has you memorize the formula. I would assume they would probably give you the formula. So the area is going to be the square root of, and then you would do 10 times 10 minus the first side times 10 minus the second side times 10 minus the third side. And then you're going to multiply all those together. You're going to take the square root and you're going to get the square root of 200, which is 100 times 2. So that's 10 root 2 meters squared would be the area of that side, side, side triangle. So let's see how the law of cosines works on a story problem. So you have two ships that leave the port and they're 19 degrees apart from each other. And one ship is traveling at 31 miles per hour and the other ship is traveling at 23 miles per hour. So here's your first ship. Here's the port at 00, and here's your ship that comes out and it's traveling 33 miles per hour. And then there's your first ship. And then if you do 19 degrees, there's a second ship that's traveling out, but it's a little bit slower and it's going 23 miles per hour. And there's 19 degrees between the two ships. And here's your ship. And then the question is, how far apart are these two ships after 3 hours? So if it's 33 miles per hour, you would have to multiply each of these by traveling 3 hours, okay? And then this is a side angle side problem. So 23 times 3 is 69. So this side is 69, and 33 times 3 is 93. So the length of this side is 93. And you're looking for side C. So you would do side C is equal to the square root of, and then you're going to take 69 squared. You're going to add the 93 squared. Then you're going to subtract 2 times 69 times 93, and then take the cosine of 19 degrees. That's going to give me side C. So you put it all into your calculator at one time, and the distance between the two ships is going to end up 35.71 miles apart. So the distance here. And that's how you can use the law of cosines in a story problem. Can there be an ambiguous case when using the law of cosines? The answer is yes. And that happens especially when you have a side, 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 where you get a case that doesn't work. And so how you prevent it is when you're using side, 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 always find the largest angle first, and then you will prevent getting an ambiguous case. Thanks, everybody.